Welcome back to another video on the Maths channel. It's your teacher Muslim here. In this video we're going to be looking at summing an arithmetic series. So by the end of this lesson you'll be able to establish and use a formula for the sum of the first n terms of an AP. So let's have a look at the first thing of this lesson. Finding the sum of the first n terms of an AP when we know the last term. Here's an investigation for you. How would you find the answer to the first 6 terms of the following AP? 5 plus 15 plus 25 plus 35 plus 45 plus 55. What would the answer be to that? Pause the video, have a go yourself. Alright, well, hopefully you did something like this. That the sum of the first 6 terms is 5 plus 15 plus 25 plus 35 plus 45 plus 55. But you also realize, hey, the sum of the first 6 terms, we can actually reverse the order. 55 plus 45 plus 35 plus 25 plus 15 plus 5. And when we add them together, we get 2 lots of the sum of the first 6 terms. They will all add to 60. So if we wanted the sum of the first 6 terms, all we need to do is, well, there's 6 of them, 6 times 60, and divided by 2 because of that 2 there. So that's pretty much 3 times 60, which is 180. So if we were to use that and actually create a formula from it, what formula would you create to find the sum of the first n terms of an AP? Well, the sum of the first n terms is equal to the number of terms. See how there were 6 here? That's where we got the 6 divided by 2 from that times whatever the first term is plus whatever the last term is. Well, the first term is 5, the last term is 55, and when we add them together, we get 60. That's how we got this 60. Now, this is a very important formula, and it's actually on your reference sheet. Okay, so we've got the sum of the first n terms. Let's just make some notations. The sum of the first n terms. So for example, if n was 7, it will be the sum of the first 7 terms. If n was 11, it will be the sum of the first 11 terms. Is equal to the number of terms divided by 2 times the sum of the first term and the last term. Okay, so that's how we read that formula. So here's an example. Find the sum of all the integers from 100 to 200 inclusive. So if we want to work out that, we need to actually work out how many terms there are from 100 to 200. Now, you might be tempted to think there's only 100 numbers, but you'd be incorrect. If I were to ask you to count how many numbers are there from 0 to 10, it's not 10. It's actually 11, because we need to include 0 as one of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually 11 numbers. So from 100 to 200, it's not 100 numbers, it's actually 101, because we need to include the 100. So we're going to sum the first 101 numbers from 100 to 200. So we know that there are 101 terms divided by 2. The first term is 100, the last term is 200. Now we can just put that in our calculator. 101 over 2 times 100, maybe I'll put a times there, times 100 plus 200 is 300. 15,150. So 100 plus 101 plus 102, all the way up to 200, that's going to equal to 15,150. Now you might notice, oh wow, that's a lot easier than having to actually add each of them individually. And yes, you'd be correct. This formula is really useful when we've trying to find the sum of an AP. Okay, when there's a common difference. Here, all 101 terms, they have a common difference of 1. It's going up by 1 each time. Alright, let's have a look at part 2 of this lesson. Finding the sum of the first n terms of an AP when we don't know the last term. Now, here's our formula. The sum of the first n terms is equal to half n, or n over 2, times the sum of the first and last terms. But what if we don't know what this is? Well, that's when the nth term formula comes in handy. We know that the nth term of an AP is a plus n minus 1d. The nth term, we can usually refer to that as the last term. So what we could do is we could substitute all of that into where the last term is here. What do we get when we do that? We can see that the sum of the first n terms is equal to half n bracket a plus, and L is a plus n minus 1d. All of that is L. Well, let's tidy this up a little bit. We have n over 2. A plus a is 2a, and then we got plus n minus 1d. Now, this formula is also in your reference sheet. I might just write the sum of the first n terms here. So please make sure you know how to use this as well. If we are not given the last term, but instead we are given the common difference, then this is what we use. So I'm just going to write this note down. Please copy this down. Oops. We use this when we don't have the last term, but have the common difference instead. Okay, so we can compare the two. I'll highlight this one in green. We use this one, use this when we have the last term, because it's got the L in it. However, if we're not given the last term, but instead we're given the common difference, we need to use the formula highlighted in yellow, because it has the letter D for difference. Okay, so make sure you know both of these formulas and know when to use them. So let's have a look at some examples. Consider the AP 100 plus 94 plus 88 plus 82 plus etc. Find the sum of the first 10 terms. Now I don't know what the 10th term is here, right? It's not given to me. But what I can do is I could work out what the 10th term is, or I can just work out what the common difference is, which is what I will do. The common difference here is going to be 94 minus 100. Remember, always take a term and subtract the term before it, and that gives me minus 6. So the sum of the first 10 terms is going to equal to n over 2 times 2a. Have a look at the formula. 2a. Well, a is 100. The first term is 100. So 2 times 100 plus n minus 1, which is 9. And the difference is minus 6. So let's put that in the calculator. 10 over 2, that's just 5, times 200 plus 9 times minus 6, 730. Okay, what about question B? Find the sum of the first 41 terms. How about I get you to pause the video and have a go with this one yourselves. Okay, so sum of the first 41 terms. We know that there are 41 terms, so we need to divide that by 2. Times 2a, in this case 2 times 100, which is 200, plus n minus 1, which is 40, and the common difference is minus 6. So let's put that in our calculators. 41 over 2 times 200 plus 40 times negative 6. Negative 820. All right. Let's have a look at part 3 of this lesson. Finding expressions and solving problems. Find an expression for the sum Sn of n terms of the series 40 plus 37 plus 34 plus etc. So, we know the formula. We don't have the last term. So we're just going to use the formula with the common difference. The sum of the first n terms is equal to n over 2 times 2a plus n minus 1d. Well, what is a and what is d? A is 40, so 2 times 40, that's 80, plus n minus 1d. What's the common difference? Well, we can see that the difference is 37 minus 40, which is negative 3. But instead of putting it out here, I'm going to put it at the front. And replace that plus with a minus. And now I'm going to simplify this. So, n over 2, bracket 80 minus 3n plus 3. So we have n over 2, bracket 83 minus 3n. And I'll leave it at that. Alright, what about question B? The sum of the first 10 terms of an AP is 0, and the sum of the first and second terms is 24. Find the first 3 terms. Alright, so the sum of the first 10 terms, we know it's n over 2 times 2a plus n minus 1d. But we know that's equal to 0, according to the question. Let me just simplify this. So that's 5. 5 times 2a is 10a plus 45d. And we know that's equal to 0. What about the second bit of information? The sum of the first and second terms. So we know that the sum of the first 2 terms, which is n over 2, times 2a plus n minus 1d, we know that's equal to 24. But I'm going to, again, just simplify this. That's just 2a plus d is equal to 24. And so, in order for me to work out the first 3 terms, well, I need to know what the first term is, and I need to know what the common difference is. So I'm going to solve these 2 equations simultaneously. I might multiply this one by 10. So here's our statement 1, here's statement 2, and I'm going to multiply this one by 5 to get statement 3. So statement 3 I'm going to write underneath here. 2a times 5 is 10a. D times 5 is 5d. And 24 times 5 is 120. Good. Alright. Next thing I'm going to do, solve by elimination. I'm going to subtract. So 10a minus 10a, they cancel each other out. 45d minus 5d is 40d. And 0 minus 120 is negative 120. So we can see here that the common difference has to be negative 3. We've done that. Now we need to work out what the first term is. So I'm going to sub that into probably this one. That makes it nice and easy. So let me just put a box around this. Right, so we've got 2a plus minus 3, which just becomes minus 3, is equal to 24. So 2a is equal to 27. A is equal to 27 over 2. Okay, or 13.5. So that means the first three terms. Well, we know the first term already, 13.5. The second term, well, we know because it has a common difference of negative 3, it needs to go down by 3, so this has to be 10.5. And the third term has to be 7.5. So if I were to write out the AP, okay, the series, it would be 13.5 plus 10.5 plus 7.5 plus etc. Okay, and that's what the AP is. But the question doesn't ask us to do that. It just tells us to write the first three terms, so I will just write that. Okay, question C. Evaluate 9 plus 14 plus 19 plus all the way to 224. Now, this tells us that this is the last term. And this is the first term. So I would use the formula that the sum of the first n terms is equal to n over 2 times a plus l. The thing is, we need to know how many terms there are from 9 to 224. So in order for me to do that, I'm going to use the nth term formula. The nth term is equal to a plus n minus 1d, right? Because this is an AP, there is a common difference of 5. It keeps on going up by 5 each time. So this is the formula we use for APs. And we know that the nth term, or the last term, is 224. So I'm just going to use a colon here. Well, A is 9. We don't know what n is, but the common difference is 5. So I'm going to put that at the front. Let's solve this now. 224 minus 9 is 215. Divided by 5 is 43. So n minus 1 is equal to 43. N is equal to 44. So if we want to add this 9 plus 14 plus 19 all the way up to 224, we need to actually work out the sum of the first 44 terms. Now that we know that 224 is the 44th term. So that's going to equal to 44 over 2 times A, which is 9, plus L, which is 224. What does that give us? 22 times 9 plus 224, 5,126. All right. Question D. For what value of n is the sum of the first n terms of 2 plus 11 plus 20 plus etc. equal to 618? Now we can see here it's got a common difference. It's going up by 9 each time. So we know it's an AP. Okay, I know this whole lesson is about APs, but just get used to checking whether it's an AP or a GP. Look for a common difference or a common ratio. So for what value of n is the sum of the first n terms equal to 618? So I'm just going to write down the formula. S of n is equal to n over 2 times 2a plus n minus 1d. Now you might be wondering, why did I use this one and not n over 2 times a plus l? Well, it's because I don't know what the last term is. Right? I don't know what the last term is going to be for when I add all of these terms together, it will equal to 618. But I do know what the common difference is, and that's 9. So we've got n over 2. And we know that's equal to 618. So let's put that in. So we've got n over 2 times 2a. Well, a is 2, so we've got 4. 2 times 2 is 4. Plus n minus 1 over times d. We know that the common difference is 9. So I'm going to put 9 at the front. N minus 1. Alright. I'm going to multiply both sides by 2. So this will give me n bracket 4 plus, I'm going to expand this out, 9n minus 9 is equal to, well, what's 618 times 2? 1236. The next thing I'm going to do is I'm going to expand the brackets on the left, but I know that we've got, when I simplify this, this will be 9n minus 5. So n times 9n, which is 9n squared, n times minus 5, which is minus 5n, and that's going to equal to 1236. I'm going to move everything to one side and make it equal to 0, and then I'm going to factorize and see if I can solve this. So this gives me 9n squared minus 5n minus 1236 is equal to 0. Now I probably wouldn't be bothered trying to factorize this, so I'm just going to use the quadratic formula. N is equal to minus b plus minus the square root of b squared minus 4ac. Oh, that's negative. All over 2a. Let's see what we get. So when we square root, actually let's not do the square root. We've got 5 squared minus 4 times 9 times negative 1236. That's 44521. What do we get when we square root it? Oh, okay, good. So we get 5 plus minus 211 over 18. 5 plus minus 211 over 18. The thing is, if we were to subtract it, we'll get a negative number, and we can't have a negative term, as in like n cannot be negative. So really, it should not be plus minus, it should just be plus. Right, because n has to be a positive integer. Let's add 5 to that, divided by 18. We know that n is equal to 12. And I think that's it. So, therefore, n has to equal to 12. There must be 12 terms of this sequence, of this AP, of this series, that when we add the first 12 terms, it will add to 618. Alrighty, question E. The sixth term of an AP is 23. And the sum of the first 10 terms is 210. Find the sum of the first 20 terms. So let's see what we can do with this. We know the sixth term is 23. The sixth term, which is a plus n minus 1d. Well, n minus 1 is just 5. And we know that the sixth term is 23. The sum of the first 10 terms. So this time we're using a sum formula. We know that the sum is equal to 210. Now the sum formula is n over 2 times 2a plus n minus 1 d. Now you might be wondering, why did I use that formula and not the other one? Well, that's because here my sixth term is in terms of a and d. So when I'm creating my equation for the sum formula, I want it in terms of a and d as well, not in terms of a and l. Otherwise there'll be too many variables. Now we know the sum is going to equal to 210. I'm just going to expand this out. We know n is actually 10, so 10 divided by 2 is 5. So we've got 10a plus 45d is equal to 210. So here's my first statement, here's my second. I'm going to multiply the first statement by 10, and that will get me my third statement. I'm going to write it underneath my second statement. So times that by 10, now will give me 10a plus 50d is equal to 230. That's statement 3. Now the reason why I multiplied it by 10 is so that when I solve these two equations simultaneously, I can eliminate a. Let's subtract. 10a minus 10a is 0, 50d minus 45d, that's 5d. 230 minus 210 is 20, so d is equal to 4. So I know the common difference is 4, but I still need to work out what the first term is. So I'm going to sub that into this one, because that's nice and easy. A plus 5 lots of 4 is equal to 23. A plus 20 is 23. So a is equal to 3. I'm just going to box these. Okay, so we found the first term, we found a common difference, and now we actually need to answer the question. The question says find the sum of the first 20 terms. So sum of the first 20 terms is equal to n over 2, 20 over 2, times 2a, well a is 3, so 2 times 3 is 6, plus n minus 1d, n is 20, so n minus 1 is 19, and the common difference is 4. So let's sub that in. 20 over 2 is 10, 6 plus 19 times 4, 820. So we can see here that the sum of the first 20 terms is 820. Alright, last one for this lesson. Evaluate the sum of 3r plus 2 from r is equal to 1 to 50. Okay, so what this is saying here, because that symbol means sum, so we know it's a series. The first term will begin when r is equal to 1, and the last term is when r is equal to 50. Okay, so the first term a is when r is equal to 1. 3 times 1 plus 2. 3 plus 2 is 5. So the first term is 5. The last term is when r is equal to 50. 3 times 50 plus 2. 152. Now, if we want to work out how many terms there are from 1 to 50, we should just know it's 50. Right, 50 terms from 1 to 50 inclusive. I think the best way, or the easiest way to do this, is just do 50 minus 1, but always add 1 at the end. 50 minus 1, that's 49, plus 1, that's 50. That's how we get our 50 terms. So if we were to scroll up to previous questions, let's see which one. Like up here, the 100 to 200, what we could have done is just 200 minus 100 plus 1. That gives us 101 terms. Okay? All right. So we want to evaluate the first the sum of the first 50 terms. So the sum of the first 50 terms will be n over 2 times a plus l. Okay, because we know the last term, so that's the formula we use. 25 times 5 plus 152 is 3925. And that's it. So now you should be able to establish and use the formulae for the sum of the first n terms of an AP. I hope you found this video helpful. Have a fantastic day, everyone. This is Mr. Lim signing out. Peace.